Hello friends, myself Kamlesh Satish Kumar from Department of Physics, Abasai Magate, Arts and New Commerce Science College, Rajapur. Today we are going to study the chapter sound. The chapter sound consists of the transducers and their characteristics, pressure microphone, moving coil, loudspeaker, and the process of recording and reproduction of sound in compact discs. These are the number of reference books followed for to study the chapter here. So the sound is nothing but the mechanical longitudinal vibrational wave of a medium by which the energy is transferred through the medium. The medium may be elastic and inertial. When acted upon by a vibrating body, it undergoes alternative compressions and rarefactions which travel through the medium with some velocity. The sound term is sometimes restricted to those vibrations which are audible to human ear, that is the vibrations with the frequency range of about 20 Hz to 20 kHz, which is audible frequency. Now let us study the transducers and their characteristics. So first of all, let us see what is the transducer. The transducer is nothing but one of the devices which can convert one form of energy into another form. The classification of transducers. The transducers are classified according to their uses or the applications and the method of energy conversion. They are classified into the number of ways. The first is the electromechanical transducer. The transducer which converts the mechanical energy into electrical energy is called as the electromechanical transducer, whereas the thermoelectric transducers are the devices which converts the thermal or heat energy into the electrical energy. For example, the thermistors, thermocouples, these are nothing but the thermoelectric transducers. Then the optoelectric or electro-optic transducers. The function of this kind of the transducers is to convert the light energy into electrical energy. For example, the photoconductive cell, photoemissive cell, and photovoltaic cells are the examples of these optoelectric transducers. Then the biological transducers. There are a number of biological transducers are there. For example, electrocardiograph, that we can say in short ECG transducer. These are used to diagnosis of heart. Then the EEG, electroencephalograph, it is used to check the activity of the brain, whereas the electromyograph, EMG, it is used to diagnosis of nerve and muscle abnormalities. Then the chemical or electrochemical transducers. These transducers convert chemical energy into electrical energy. For example, the conductivity cell. So in short, we can say about the transducer that the transducer is the device which converts one physical quantity or any physical quantity to the electrical quantity. The electroacoustic transducer is one of them. The device which converts the electrical energy into acoustic, that is a sound energy, and vice versa, is called as the acoustic or electroacoustic transducer. The common acoustic transducer is nothing but the microphone, which converts the acoustic or sound energy into electrical energy, and the loudspeaker, which converts the electrical energy into acoustic energy. There are a number of characteristics of the transducers. That is, we are studying basically the acoustic transducer and how the acoustic transducer should be. There are a number of characteristics to follow. The number one is the transducers should have efficiency approaching of about 100%. They should have uniform response to a whole range of audible frequency. This is called as fidelity. The output of transducers must be pure and should not be modulated, that is mixed by any intermediate signal. That is, the output should be free from noise or unwanted harmonics. Then another characteristics of the transducer is that the transducer must be sensitive or responsive even for the smallest changes of audible frequency. The transducer, especially the microphone, should be capable to catch the sound waves from all directions. This characteristic is also known as the directivity. Then the transducer should have sufficient size, maximum durability, and minimum cost. But in practice, there is no one device which can satisfy all these properties. So we have to choose an appropriate device considering the local demands of situation. Let us see the transducer microphone. As we studied that the microphone is an acoustical device, or it is acoustic transducer which converts the sound energy into electrical energy. It is an acoustic transducer that converts the variations of sound intensity into alternating current, that is nothing but the electrical signal, that can be further amplified and transmitted to the desired places through telephone lines or cables. At the receiving end, the electric currents are converted back into sound waves by loudspeaker or headphones. Therefore, the microphone plays an important role in broadcasting, recording, and telephone, etc. systems. The classification of microphone. The most commonly used microphones are divided into two classes. The first one is the pressure microphone, another is the velocity microphone. The velocity microphone, when the sound waves propagate through the medium, the particles of the medium starts vibrating with a particular velocity. The velocity of microphones gives the response or are sensitive to these particle velocities. Then the pressure microphone. The pressure microphone gives a response to the changes caused by the pressure of the medium due to the sound waves. The pressure microphones are of four types here. The one is the carbon microphone, second is the capacitor microphone, third is the moving coil microphone, and fourth one is the crystal microphone. Let us study some of them. Let us study first the carbon microphone. This type of the microphone is designed by Edison and Hughes. The principle on which the carbon microphone's working depends is that it works on the principle that the resistance of carbon granules varies in accordance with the applied pressure. The pressure is of course, due to sound waves. This is the diagram, or we can say the constructional diagram of carbon microphone. In this microphone, the carbon granules are enclosed between a diaphragm shown by the capital letter D. This diaphragm is nothing but a small partition, and the metal plate P1. The diaphragm responds to even for small changes in pressure. It is indicated by capital letter D, whereas the metal plate P1 is also there, which is indicated by the letter P1. The diaphragm D and the metal plate are connected in series with battery, shown by V, through a key K. The secondary windings of the transformer is connected to the telephone receiver. The sound waves are allowed to fall over the diaphragm. Due to the incident sound waves, the diaphragm set into vibrations, and the carbon granules are subjected to the changes in the pressure. When the key K is closed, the steady small current I equal to V divided by R flows through the circuit. If a person speaks in front of the diaphragm, it's set into mechanical vibrations so that the carbon granules start compressing and decompressing, due to which the resistance and therefore the current of the circuit changes. If R be the resistance of the circuit, when there is no displacement of the diaphragm, and let Ka sine omega t be the amount of changing resistance due to the displacement. A sine omega t at any instant t, where K being the constant of the microphone, then the total resistance of the circuit at any instant will be R plus Ka sine omega t. Let V be the EMF of the circuit, then the amount of the current at any instant can be given by the equation I equal to V divided by R plus Ka sine omega t. There is further calculation is also there, from which we calculated one of the equation. The first term in this equation indicates the steady current when the diaphragm is at rest, whereas the second term indicates an alternating current of the same frequency. as is impressed on the diaphragm, and the other terms indicate the harmonic waves of the same frequency. The current is therefore said to be modulated. This modulated electrical current passes through the primary windings of the setup transformer, which induces the similar but amplified changing current in the secondary windings of the transformer. This amplified current passes through the telephone T and excites its diaphragm. Due to the movement of the diaphragm of telephone, the air near it start vibrating with the corresponding vibrations and reproduce the original sound. Then the carbon microphone.